Module 5, Lesson 6 problem set is going to look at equivalent fractions again. So each rectangle represents 1. This whole amount represents 1. You're going to draw horizontal lines to decompose each rectangle into fractional units as indicated, using the model of the shaded area as a sum and product of unit fractions, which we'll talk about. Use parentheses to show the relationship between number sentences. The first one has been partially done for you. So what we see here is when we look at this as columns, we have 3 columns with 2 out of 3 being kind of highlighted, hence the 2/3. But then they went ahead and cut it in half, making it to 1, 2, 3, 4, 5, 6, which means when we count the amount of shaded, we have 4 out of 6 shaded. So 2/3, what it shows is equal to 4 over 6. In other words, 1/3 and 1/3 equals 1/6 plus 1/6. That would be the first third. 1/6 plus 1/6, the other third, or 4/6. They took those kind of unit fractions, 1/6, 1/6, 1/6, 1/6, and recognized that it's 2 times 1/6 and 2 times 1/6. 2 times 1/6, 2 times 1/6, making 4/6. Or 2/3 equals 4 times the unit fraction of 1/6, or 4/6. In this case, what we currently have is 1, 2, 3, 4, 5, a denominator of 5 with 2 shaded. So in this case, if I wanted to shift this from 5 to tenths, I'd have to cut it in half. So now this would represent tenths and 4 items shaded. So when we go over to the side here, sorry, I didn't show that in the screen. So we had the 2 columns would be 2/5. When I cut it in half, it would be 4 pieces out of 10. So we're going to say that 2/5 equals 4/10, and we're going to prove that. Okay, so 1/5 plus 1/5 is equal to 1/10 plus 1/10. That would equal this one, plus 1/10 plus 1/10, which represents this 1/5, giving us a total of 4/10. Those 1/10 plus 1/10 plus 1/10 plus 1/10, and we're prioritizing, so this would represent that 1/5, this would represent this 1/5, equals the same thing as 2 times 1/10 plus 2 times 1/10. And all we're saying is instead of adding the repeated addition, we're just going to say 1/10, 2 of them. And that would still equal that 4/10. When we isolate this unit fraction, okay, when we isolate the unit fraction, 2/5 equals 4, 1, 2, 3, 4 unit fractions times 1/10, which would give us our answer of 4/10. That's a lot of work to kind of go to the commutative property and distributive property to represent how many it would be broken down to when looking at a multiplier and a unit fraction. For the remaining problems, you're going to continue to do the design. So for instance, this is 4ths, and you need to make it into 12ths, so you would actually draw 2 horizontal lines. And the problems down below, you're just going to represent as area models and then the decomposition. So in this case, I'm going to take this rectangle, I'll make 3/5 shaded. And then how do I get to 6/10? Well, I would break that in half, and now it represents 6/10, and do the kind of unit fraction saying that it would 3/5 equals 6 times 1/10 based off that information, as well as following the directions here.